So we're going to be looking at limits at infinity. Okay, so for example, if we have a horizontal asymptote, and we have a graph that approaches that going as x's get really large or as x's get really small. So it comes and it gets close to that asymptote, but it never touches it. Okay? So when you're looking at a horizontal asymptote, we would say, if this was the function f, we would say the limit as x approaches infinity of f of x would be whatever this y value is. Okay, so would be equal to L. So the way that we define that formally bless you. Okay, so the statement the limit as x approaches infinity of f of x is equal to L means that for epsilon greater than 0, there exists an m that is greater than 0 such that the distance between the function and the limit is less than epsilon whenever x is greater than m. So what that's saying is that there's a distance around our limit. Okay, so this is, you'll remember from the definition of derivative that we said we're going to let this distance from L be epsilon greater than L or epsilon less than L. Okay, so it's a range of values. Okay, and what it's saying is as we pick some value out here, m, and we say as long as the x value that I pick is greater than m, as long as it's out here, then the distance between the function and the limit is inside of that range. Okay, so it's less than epsilon. So this is saying the distance of this function and the limit, which is this horizontal asymptote here, is less than this distance epsilon that we have here. Okay, so we can choose some value m, and as long as we choose x values that are greater than that, then the distance between the function and the limit is going to be less than that epsilon value. Okay, so that's what it means for the limit as x gets really large, it goes to infinity, to be equal to L. Likewise, in the other direction, the statement, the limit as x approaches negative infinity of f of x equals L means that for epsilon greater than 0, there exists an n value that is less than 0 such that the distance between the function and the limit is less than epsilon whenever x is less than n. So on the left side of the graph, you're choosing some n value here, and it's saying as long as I choose x is smaller than that, the distance between the function and the limit is going to be less than this epsilon amount. Okay, any questions on that? So that's the formal definition of limits to infinity. And that's on page 239. Okay, then if you look on page 240, the definition of a horizontal asymptote. So we all know what a horizontal asymptote looks like, and we've used them since college algebra and before. So this horizontal asymptote L, it says the line y equals L is a horizontal asymptote of f when the limit going both directions is equal to L. So the limit as x gets very large, goes to infinity of f of x is equal to L, and, or, not and the limit as x approaches infinity of f of x is equal to L. So it can be both. It can be and or. Okay? So in this example that I showed you up here, it's both, right? But you can also have a graph where you have a horizontal asymptote, something like this is my horizontal asymptote. My graph could just go up to that horizontal asymptote on one side as x gets large. Okay? Any questions about those definitions? All right, so let's look at some examples. Turn to page 246.